Hello, my name is Eric Carlson. Today we're going to be reviewing how to take a SDM from the NRAO archive and using the science-ready data products calibration tables to gain a calibrated measurement set, which we will then split off and export for use in DIFMAP. So the first thing that we're going to do is we're going to go to data.nrao.edu. And that page is going to look something like this. Now, the first thing you'll notice is that I'm signed in. You do not necessarily have to be signed in to get data from the NRAO archive. This is good if I want to directly push this data to my Lustre account, but it is also required if I'm accessing new data, which is locked still. And that's what we're going to be doing today, is using a measurement set or an observation, which was just recently observed as part of my own work. And to get that, what I'm going to do is I'm going to use the search bar here, and I'm going to use the PI's name, or in my last name, to sort the different observations that have a PI with the name Carlson. I can also search directly by project code, or I can go to the search inputs button, and I can search by frequency, right ascension and declination, change different telescopes in the drop-down menu, array configuration, the various receivers, etc. Now, in this case, I want this 23B-297 observation. So what I'll do is I'll click this plus button here. And what that's going to do is it's going to open up more information about that project code. So here is our title, the abstract, which we wrote for this particular observation, the PI's name, and the co-authors. Now, what we can do is we can see here that for sources or observations that have undergone the science-ready data products, you'll see here that these little files that if I hover over are tarballs. These are going to be the cal tables which I will be applying to the SDM. Now, you can also go over here and you can click on scans. So it'll open up a new tab, but it'll also give you information about the scan duration and the scan intent. So in this case, we can see that we were on target for this particular observation for 319 seconds. So returning back to our original tab, to select the data, I'm going to click this clipboard icon here that says select for download. And then what I'm going to do is I'm going to click download. Now, in a future video, I'm going to show you how to use and run the CASA pipeline. But for the purposes of this tutorial, all we're going to do is we're going to click the calibrated measurement set button. Now, if you want to apply flags that were generated during observing, you would leave this button checked. We can also select which version of CASA we'd like to use. Generally, the most recent version of the VLA pipeline is the recommended version. However, for some observations, it might benefit you to use a previous version of CASA, particularly the one that the pipeline was run on this measurement set with. We can also, in the case where the science-ready data product initiative reran the pipeline and restored different calibration tables, we could select different calibration measurement set tables by selecting this button. In the case of this particular observation, only one cal table exists, so we're only provided one option. What we're going to do is once we are ready, we are going to click the Submit Request button. And then we're going to be taken to a page that looks like this, that tells us that we have initialized our request, and eventually we'll come back to this page, or we will use the email link that is sent to us to retrieve our data. So once our data is fully processed, we will get an email that looks something like this, that will say, "Dear requester, thank you for using the NRA archive." And as we can see, we can go back to that original site here, and it'll tell us that our request was completed and that we have a file that we Now, the recommended method is to use wget or wget2. And what we'll do is we can copy this link and we can download this data locally onto our devices, or due to the size of many of these observations, we'll be using the NRAO's compute cluster to actually transfer this data over, split off our targets of interest, and then we will download the targets of interest onto our local machines. So back to our terminal, what we can do is we can log in to our observer account. So that's going to be obviously SSH, and then your observer number, and then at ssh.aoc.nrao.edu. So I'm going to input my password here. And the first thing that we're going to do is make a working directory. So we can do that using the makedir command. And we would hit, I've already created this directory. What we're going to do is we're going to SSH into our master node. This is going to be SSH nmpost-master. So once we have successfully logged into our master node, what we're going to do is we're going to request an interactive node, and it is only on that interactive node that we can run CASA. So when we're on the master node, we'll run the node scheduler command. So that's going to be node scheduler, and we're going to use the request flag, and then we're going to request the number of days that we'd like to use the interactive node for. So the maximum number is 14. In this case, we'll request the interactive node for 1 day. And when we are done with this reduction, we will release this interactive node back into the pool. So that's going to be node scheduler request 1. Once we do that, we'll get a notification that our request has been submitted. And then what we will do is we can run the sq me command. And what we'll see is that we have been assigned an interactive node on nmpost 008. Now, to get to nmpost 008, we will SSH over to that. And from here, we can finally change directory into our working directory for this observation. Now, what we're going to do is we're going to go back to our wget command, and we're going to copy this, and we're going to paste this into our terminal. Now, at this point, you'll hit enter and you'll wait for the observation to download. But for the sake of this tutorial, I have already done that. We can see this by physically listing our directories. Now we have 2 directories here. The one with the calibrated measurement set is going to be the explicitly long with the scheduling block number listed in the name. So what we're going to do is we're going to copy this, and we're going to change directories into that measurement set. Now, as we list the files in that directory, we can see that we have a .ms, which is a measurement set, and that is going to contain our calibrated observations. So from here, we can run CASA-VLA to grab the most recent version of CASA that has been validated on the VLA. So we get an error here that CASA cannot connect to an X server. That is okay in this case, as we are not going to use any plotting commands on the NRAO server, and we are simply using it to split off our data. Now, when we're here, we want to list the observations. So we're going to use the list_ob command, and we're going to name our visibility. So in this case, that's going to be 23B-297. I'll use tab to complete, and then it'll give us .ms. And then we're going to provide it a file name that we want to write out. So you can name this anything you like. I generally go with listobs.txt. And from here, we'll hit enter. So we'll get an output to the command line. But actually, what we want to do is we want to exit out of Casa and use nano to actually see our list observations. So here we have it broken up. We have the date of observation and the actual UTC time upon which we observed the various scans. And we can actually run over to the side over here. And we can actually see what scan spectral windows that we were observing during the scan, as well as the integration times for those scans, for those various spectral windows. And we also get the reason why we were observing that particular scan. So that's the scan intent. And so for this one, we're doing system configuration. The next one, some more system configuration. Then we calibrated bandpass, delay, flux, complex phase, and then we started observing our target. And then we finished with our complex gain calibrator. Again, farther down, we have our list of observations. So again, we have our flux, phase, and our target. And finally, of most importance, we have our spectral windows, the number of channels in each spectral window, which we need to make note of if we are exporting to DIFMAP, as well as the starting and ending frequency for those observations, and what polarization. In this case, we did full polarization, so we have both the parallel hands and cross hands data. So once we have taken note of what the number of channels, we can make a couple of decisions. So for this particular observation, I want to export field number 2. I want spectral windows. Say I want a high frequency S-band observation. So I want spectral windows, let's just say 14 and 15. And I make note that there are 64 channels in our observation. So once we have all of that information, we can run back and we can go back into Casa. So the first thing we're going to do is we're going to run the split command, and we're going to, again, use the viz modifier, identify our measurement set. We're going to tell it that the data column we want to work on is going to be on our corrected data. We are going to say that we want to work on spectral windows 14 and 15. We want the field number 2. And for DIFMAP only, or in other cases where you want to average over the channels, we're going to tell it that the width we want to average over is 64 channels, and this gets inputted as an integer. Now, this is going to produce a single spectral window channel, or a single channel for each spectral window. If we said a width of 32, then we would get 2 channels per spectral window. In DIFMAP, DIFMAP ignores the base channels and averages over the channels automatically. Now, to save file size, if we give the width equals number of channels, that's going to do the averaging up front and allow for faster load times and smaller sizes in DIFMAP. So with all of that said, we need to name an output viz file. So this is going to be J1548. This is going to be a spectral window 1415. And we're going to give it the .ms suffix. And with all of this, we're going to hit enter. Now, as we let this run, this will, again, subselect out our corrected data, our spectral windows 1415, fields 2, which is our J1548 source, and average over the channels. So we'll come back when this is done. Okay, so once our data has split off, what we'll see is we have, if we list our files here, we have our measurement set that has been split off. Now what we're going to do is we're going to use the export UV fits command. We're going to give it the measurement set which we just split off. Now that we've split off the data, the corrected column has moved from the corrected column into the data column, and the corrected column is now left blank. So for our new measurement set which we created, the corrected data is now in the data column. So we need to define that that is where our data is. We do not need to define spectral windows because we are going to be exporting the two that exist in the 1548 file which we split off. We do not need to specify the field because we only have one field in that measurement set which we split off. We do need to run the pad with flags command for DIFMAP. The other thing we need to do is we need to give it a fits file name. So in this case, it's going to be J1548. It was taken in A configuration in S band, and this is going to be a UV fits suffix. And then just in case I had a previous file named this that I wanted to overwrite, I can use the overwrite equals true command. Now, once I've done all this, I can hit enter again. And what we'll see as this goes, we will get a progress bar with the percentage at which the observation is being written out. So when this is complete, we will come back and I will show you how to get the data off of the NRAO archive and load it up into DIFMAP. Okay, so once our data has finished outputting here with export UV fits, what we'll do is we'll print the working directory to the terminal. We will then load up a new tab here, and we will use SFTP into our observer account. And then what we'll do is we will tab over, grab our working directory, and cd into that working directory. And what we'll see here is that we can grab our UV fits file. And then once we've done that, again, we can open up a different file. And what we have done here is exported our data for DIFMAP, and it is ready to go. And actually, we can see that if we actually plot our data, we have that nice snowflake that is, we can actually see some of the underlying structure of this particular source here. So that is our complete guide to using the Science Ready Data Products calibration tool, or calibration tables, to apply them to our data and then export that data to DIFMAP. So feel free to ask any questions in the comments, and I'll do my best to reply to them.